Okay, so section 3.2 is the multiplication rule. All right, so we need to identify the dependent and the independent event and how do you use the multiplication rule. All right, and conditional probability here is using the P of B given A is already occurred. All right, so that's a conditional probability. I usually like to using like what is a conditional probability, right? So for example, given you already got a full shot, okay? If you already got a full shot, what is the chance you're gonna get a flu? All right, so that's given this condition, okay? We have a general population, like I said, some people didn't get a flu shot, right? And they get a flu. So that's one kind of probability. But right now I'm interested in for those people actually getting the flu shot and they still develop a fruit or they still caught whatever, they still got a fruit, right? So what is the probability would be that one. And that would be called a conditional probability. Okay, and I am very sure like if you got a flu shot, the chance you're gonna get a flu is smaller. It's not zero, but it's smaller, right? It's smaller than people do not get a flu shot and get a flu, right? So that is this one right here. And sometimes we usually also compare these two groups and then trying to see the effective rate of the flu shot, that kind of thing. So that is called a conditional probability. Okay, so look at this one right here, and then we using this kind of card a lot. Two cards are selected in a sequence from standard deck. So the standard deck, that means did not include joker, okay? For the probability that the second card is a queen, given the fourth card is already a king. And I think I actually have a little bit, in a drive, okay, in a share folder. I put all the card in a share folder. So let me showing you where is that. I think in a share drive. Okay, right now I couldn't really find a share drive. All right. OneDrive right here. Okay, all right. In this share drive, you actually have the key formulas and the table right here, right? And then you have a list standard card. Look at it. So this one, if you need, you can print it out. So you can look at how many different cards in here, right? So this is called a standard card, and then you have A, you have a Jack, a Queen, King. Jack, a Queen, King. Sometimes we also call it a face card because that's the one having face. So that's a face card, right? And the heart and this one spade and the diamond, these are all red card, right? And the club and spade, those are the black card. Something like that, right? So if you are not quite familiar with this one, you can print it out and it will give you a little bit familiar with that. Okay. All right. So you have two cards selected in a sequence. So that means you select one and then you select another one, right? You want to find a probability that second card is a queen. Okay, so second card is a queen. Given the fourth card is a king. All right, so if the fourth card is a king, and if you do not replace them, okay, so that means the fourth card is out. All right, do not replace them. That means you only have a 51 left instead of 52 total, right? So you're gonna have 51 left. And how many of them are queens? Well, the four of them are queens. So this one will be 4 out of the 51 giving. So that's called a condition. Giving the fourth one is already a king. That means the king is taken out, do not replace. Okay, so you only have a 51 left. All right, so that is called a condition probability. Okay, a little bit tricky, this one. All right, look at this one right here. This is a table, right? This is a survey in which this 2,276 social media users was asked whether they have ever been offended by something they saw on the social media. And this, you want to find a user is male, giving the user was offended by something they saw on the social media. All right, so this is another conditional probability, giving the user was offended. All right, so the giving, so that means we are not going to look at the entire total. So this giving here, that's the condition. We will just only consider that they answer yes, they are offended. So find a probability that the user is male. So that's what I can write down. This is male. Giving the this one is called yes, offended, right? So we're gonna just look at this column only. Okay, look at this offended column only. And the total here is 1151, right? And giving the male said they were offended, that's 532. Okay. All right, so you can see, this one probably a little bit less than 50%, right? So you can see like a female are usually a little bit more sensitive to those social media, according to this survey, right? The Harris poll in here. So male, yeah, actually, it's still a good percentage, So let's go ahead and give you a quick calculation. All right, so that's about 46%, right? So 0.462. Okay, so if you see something from the social media, about 46.2% of the male will feel offended, right? And then if you look at the female, this male and female added together is 100%. So the female will be like a 53.8%. Right, 53.8%, a little bit more than half of the female will feel like offended that way. Okay, so that is how you do this type of probability, giving these conditions that they are offended. All right, so this is showing you, you look at the male, right, and then you go to look at the total in here. Okay, so look at the male, which is 532, and divided by the total. All right. Okay, so what's a dependent and independent event? Dependent and independent event here is if event A happened did not affect event B happen, that's called independent. If event A happen, we are afraid the other event happen, that we call it dependent, right? So for example, I usually say if you go to the gym every day and compare to your math test score, well, if you go to the gym every day, it doesn't really affect your math score, that kind of thing. It is from, just from the two events are not related, right? So that would be called an independent event, right? But if someone tell me, say, I'm going to tutoring center every day, a math tutoring center, okay? I'm going to the math tutoring center, which you can go any campus that close to you, right? Every campus has a tutoring center, all right? So if you say, I'm going to the math tutoring center every week and every day, and my math test score, and I'm saying these two will be dependent, right? Given the more you go to the math tutoring center, I think your test score will get better, okay? I would say, so these two events I would consider is dependent, right? But when you say you go to the gym every day and the math test, I would say those two will be independent, right? One doesn't affect the other, so it'll be the independent. Okay. All right, so look at this one right here, classifying the event dependent or independent, right? You select the King A from this standard deck of the 52 cards, not replacing it, and then select B from the deck. All right, so if you take a out, take a King out, and not replacing it, and you're gonna have a probability of selecting the queen from the deck. Is this dependent or independent? Anyone? Just type it on the chat. Say dependent, just DE, or independent, IND for short. So you take one out, you're not replacing it. What's the probability getting a B, a queen? Will it be bigger or smaller? Or does that affect that? Dependent, smaller. Okay, all right, very good. I'm so happy to see that. Yeah, that would be dependent, right? Because you take the A out and you are not putting that back, and the chance you're gonna get a B, right? Maybe I can take a several out and not putting that back, and the chance I'm gonna getting the queen, if as long as you take the card out is not queen. If I move everyone else out and then the queen still there, yeah, that will affect my chance to get a queen. So that's dependent. Okay, very good. All right. Tossing a coin and getting a head, and then you're loading a 6-side dice getting a 6. So is this dependent or independent? You toss a coin and getting a head, and then you loading a dice getting whatever, a 6 or 3 or 2 or 1. What do you think? Dependent or independent? Independent. Okay, very good. That's exactly right. All right, very good. Okay, so this one is you tossing a coin and rolling a dice. These two are not affect each other. Okay, each one is do their own thing, right? It doesn't connect. It doesn't affect each other. So yeah, that's independent. Okay. All right. So why we want to know dependent and independent? Because the way we calculate probability will be different. Okay. So those concepts you need to know. This one say driving 85 miles per hour and getting a car accident. What do you think? If you're driving in a high speed, 85 miles per hour, consider a high speed, right? And then getting a car accident. Well, if you drive a high speed, the chance you're gonna get an accident will be higher. Okay, so this should be a good one. Will affect the other, so this should be considered as what? Dependent. Yeah, this should be considered as dependent. Yeah. All right. Okay. All right, so we are using the multiplication rule to find the probability. Okay, so this multiplication rule, if A and B are independent, okay, A and B are independent, we are just, if this is independent, you just using probability of A times the probability of B. Okay, so that's independent. If these two are dependent, okay, if these two are dependent, now you're gonna using probability of A times the probability of B giving A is already happened. All right, so that's called a dependent. Okay, seems a little bit abstract, but we're gonna have some example in here. All right, so look at this one right here. If you select two cards without replacing that, without replacing the fourth card, that means the fourth card is already up, right? From this standard 52 cards, find the probability of selecting a king and then selecting a queen. All right, so when you see the N, so this is two events in here. This is two events. Event 1 is getting a king. Event 2 is getting a queen, right? You can see there's two procedures in here. All right, so this one is using an N, so you will need to multiply using the multiplication rule. All right, so these two events are continuously, so you need to multiply together, okay? Because this is gonna whole thing become one event but two procedures, okay? This whole thing, find the probability for this whole thing, and this whole thing got two events, okay? The probability of selecting a king and a queen. All right, and the condition here is not replacing that. Okay, so what is the probability of getting a king at event 1 or probability 1, getting a king? Well, I have 4 kings right there, right, out of the 52. So that's my normal, the first one right here. Okay. The second one, since you do not replace that, if you do not replace that, that means I only have a 51 left, okay, and I still have a 4 queen. So I will have a 4 times 4 over 51. So that's my probability of selecting a queen given this king is already out. King is out, not replaced. Okay, so my probability here will be just 4 out of 51 for the probability of getting a queen. All right, and then I multiply these two together. That will giving me the probability of getting the first one is a king and then second one is a queen without replacing. Okay, and this probability will be pretty small, right? Because how do you do this one? You multiply numerator and numerator together. You multiply denominator with denominator together, right? And then you go to do the calculation. So you can have a 16 divide, and I'm gonna have to use the parentheses. 52 times 51, right? And now I'm giving you 0.0006. Okay, we know this probability is small. All right, or 6% of the chance only, right? 6% of the chance. You have a 20 in the middle. All right, so this will only giving you 6% of the chance that you will see that the first one is a king and then the second one is a queen without replacing it. All right, so the second one here is a coin is tossed and the die is low. The probability that tossing a head and then loading a 6. All right, so probability getting a head here, well, we know these two are independent, right? So probability of getting a head, I have a 1 out of the 2, right? Because this coin is just, one head and 2 outcomes, right? Probability of getting a 6 here will be, look at this is finding the probability, right? So probability of getting a 6, I only have a 1 6. So it's 1 out of 6. So multiply these two together, it's 1 over 12. Okay, so that is how you calculate this called a probability using the multiplication rule in here. Okay, any questions about this probability? All right, so that is called using the multiplication rule. Okay, we have one more smaller section for tonight and I will stop. The rest will be practice. Okay, so I want to go ahead cover also this section because this is all the probability in one section, in one chapter. All right, we're gonna look at the addition rule. Okay, I know this chapter sometimes people consider a little bit more challenging. So the good thing is that I have a recording, so you can go back to watch that again if you need to. But I definitely recommend you to read a textbook at least once, okay? Because when you read a textbook, you can get a whole thing combined together, the whole story connect together, not a PowerPoint, just the key concept only, okay? All right, so the addition rule here is using all, okay? Addition here usually is using all for the event. And since this is gonna be adding together, so we have two different types. One is called mutually exclusive and not mutually exclusive, right? So what's
we can't see your screen. We can't see your screen.
Yeah, we can.
Oh, you don't see my screen? For how long?
Yes.
For the past 2 minutes, I had to change device.
Oh, okay. Can you see that now?
Thinking it was me, but
yes.
Okay, yes. All right. Did you see that earlier or not?
No.
No? For the whole section, you can see the one?
Oh, no, not like about 2 minutes ago.
Oh, no, not like about 2 minutes ago.
Right. So I don't know. Yeah, thanks for letting me know because I didn't know that sometimes the screen itself would just suddenly change. Okay, all right. So not too bad, not too long ago. Okay, so all right, this one like a blue and purple, right? Blue and purple. This one, if there's nothing in common, like we wanna say male and female. Okay, hopefully I will say that correctly. Not trying to be political. But if we say male and female are mutually exclusive, okay, so that means if you count it as male, you cannot count it as a female. So that's called a mutually exclusive, right? Event A and event B cannot occur at the same time. All right. But if I say how many male and how many male students in the class and how many nursing students in the class, well, you can see if I count all the male students and I also count all the nursing students, and I know we also have a male and nursing student in the class, right? In my statistics, I always have a male and also the nursing student. Actually, if you are male and also major in nursing, you probably the first one gonna get higher because we have a less male and nursing major. We got more like a female and nursing student. Usually, they consider male or female are more like caring, something like that, right? But sometimes we also need some male nursing as well, nurse as well. So yeah, if I said the male, okay, if I said the male and female, those would be mutually exclusive, right? But if I say male and nursing student, okay, and this will be not what? Not mutually exclusive, okay, because we can have a male and also a major in nursing as well, okay. And if you add all the male and add all the nursing major students together, you're gonna overcount something in the middle, right? So that means we have to minus this middle part once. So if it's mutually exclusive, I can have my A or B will be just using probability of A plus probability of B. Just add them together because they are not mutually exclusive. Or they are mutually exclusive. I'm sorry. They are mutually exclusive. So I just add these two parts together. That's my total. All right. But if it's not mutually exclusive, I add all the male. If I say male or nursing, okay, I'm not just using N. All right. If I add all the male and add all the nursing major together, I will have to minus the male and also a nursing ones. Because if I count all male and count all the nursing, I will count those people are male and also nursing major twice. So I have to minus the at least once. Minus exactly once, that way, okay? Do not using at least, minus exactly once in here. So I can have a correct counting. All right. So look at this one right here. Is this is mutually exclusive or not? Event A loading a 3 on the die. Event B loading a 4 on the die. Is this mutually exclusive or not? The answer will be yes, because 3 is 3, 4 is 4. It's two different ones. You cannot be 3 or 4 at the same time. Okay, so this one will be considered mutually exclusive because you cannot have a 3 or 4 at the same time. All right, if I loading 1 is 1, loading 2 is 2, right? So those are mutually exclusive. Okay, look at this one right here. I just give you an example. Select a male student and also select a nursing major student. What do you think? Mutually exclusive or not? This will be not a mutually exclusive, right? Mutually exclusive, that means, yeah, that's not mutually exclusive. Mutually exclusive, that means if I have a male, I cannot be counted, major in nursing. but apparently that's not true. So this one is not mutually exclusive, right? All right, sometimes I also tell like some of my female girls student, right? I say if you have a boyfriend and then you tell them I want a mutually exclusive relationship, right? So what does that mean? That means if you are dating with you don't want to date someone else, right? So that would be mutually exclusive, right? Okay, all right. So another one is the this one you have a blood type O, right? So randomly select a donor that is type O, and also randomly select a female donor. So is this mutually exclusive or not? There should be not, right? Because you can have a female also a type O, right? Or type O can also be a male or female. So these are not a mutually exclusive, okay? All right, so I already given you the formula earlier. If it's mutually exclusive, you just using probability of A plus probability of B, right? So this is OR. When you have an OR, you're using an addition, okay? And when you're using an addition, you have to look at mutually exclusive or not. If mutually exclusive, you just add both A and B together. If it's not mutually exclusive, you add both together, but you have to minus the common part once. So that way you don't overcount, okay? All right, so look at this one right here. You see that a car from a standard deck, right? Find the probability that a car is a 4 or an A. All right, so this is a 4. A car is a 4. So you can look at the whole picture car here. All right, let's look at the whole picture car. All right, so this one is a 4, right? So if you look at this one, you see that a 4. So you have a 1, 2, 3, 4. 4 of them are 4, right? And then you also have a 1, 2, 3, 4. 4 of them are A's. So apparently 4 and A are mutually exclusive, right? Because they don't have a overcount in here. All right. So that one is mutually exclusive. So you can just add a 4 and 4 together. Okay. So that is a car is a 4, it cannot be an A's, right? Another one right here is if you so this one is mutually exclusive, right? And this one is you loading a number less than 3 and also loading an odd number. All right, so what is a number less than 3? Less than 3 you can have a 1 or 2, right? So this one you have this loading this one you have a 1, 2, 3, 4, 5, 6, right? So you loading a die and a number less than 3. Less than 3 can be 1, can be 2. And then you can also or this is or, so you're gonna add them together. Or loading an odd number. So which one is an odd number? 1, 3, and 5. They are odd number. So if you add 1 and 2 together, you count the 2 already. And then you count the odd number, you count the 1, 3, and 5 again. So that means you count the 1 twice. Okay, so you must minus this 1 time. Otherwise you overcount. Okay, so that's called a not mutually exclusive in here. Okay. All right, let's see how we do this one right here. Finding the probability in this mutually exclusive event. So why this event is mutually exclusive? Because this is sale amount. So for example, if a sale amount in this 25,000 to 49,999 have a 5 months, and then this one is starting something that is not in here, right? You have a 49,999, and then this one is start from 50,000. So these numbers are not repeated. None of these numbers are repeated. So that's called a mutually exclusive in here. Okay. If you are using this pattern, find a probability that a sale will be between 75 to 125. 75,000 to 124,999. So you're gonna add these two together. Okay, so these two are not mutually these two are mutually exclusive. So you're gonna add a 7 and 9 together, and then go to divide the total. All right. Okay, let's look at this one right here. We do the broad type earlier, right? Now we're gonna look at one more time in this table. Okay, we're gonna find the probability the donor has a type O or type A. Find the probability. Remember, every time when you say find the probability, you need to divide it by the total. If you want to find the probability, you must divide it by the total. Okay, and depends on what kind of total you have. All right, so how many of them are type O? Well, type O will be this column, right? If you look at a type O here, type O will be this column. Okay, and this is a total for the type O. All right, or type A. Or type A is this column, and that's the total for the type A. Since these two are mutually exclusive, right? So just like if you are type O, you cannot be counted as type A. So my probability, okay, so that's how you do that. Probability of type O or type A, we're gonna have to divide it by the total. Using the type O probability is 184 divided by the total is 409. Type A probability here is 164 divided by 409. Or I can add a numerator together since I have the same denominator, so I can just add a numerator together. And I can just put in a calculator and calculate. Okay, calculation should be easy as long as you can list this one. All right, so that is the first one right here. Okay. Second one right here, you want to find a probability that has a type B or Rh negative. All right, so we're gonna look at the type B in here. Type B. All right, so type B, the total type B is 45. How do you get a 45? You use a 37 plus 8. That's type B total. Rh negative. All right, so when you have a Rh negative, look at this horizontal one. So the total here is 65 for the Rh negative. But how do you get a 65? You add a 28, 25, 8, and 4. So you add this 8 again. All right, so if we use 65, if you use 45 plus 65 divided by the total, you already add this 8 using the 8 twice, so you must add this 8 once and go to divided by the total. So that will be your probability here. Okay. All right, so that is and the total here. Yeah, my total here is 409. All right, so you can each one divided by 409, or I can just write down since they have a same denominator, right? So I can just add them all together. So this add them together is 110 minus this one, right? And then that's 102 over 409, and then you can go to estimate into decimal point. Okay. All right, so that is how you do this type of calculation. Okay, this giving you a little bit summary for this this whole probability in here. Let me make it a little bit bigger so you can probably see a little bit bigger in here. Okay, so classical probability, right? So how do you do the classical probability? You using the number of the outcome in the event divided by the sample space. The sample space is the total, right? Empirical one, you're using the frequency of the event E divided by the total frequency. Okay, remember the probability is always between 0 and 1. All right, complementary probability, you can use 1 minus the other one because P and P prime add up together should be 1, right? And then if you have two events occur pretty much next to each other, this usually would be the multiplication rule. So if you look at the multiplication rule here, it's using N, A and B, right? So that means they happen pretty much consecutively that way. All right, if this is independent, you just multiply these two probability together, right? And if it's dependent, you will need to multiply the P of A and then also multiply P of the B. But this P of the B will be giving the A is already happened. So that's the probability of B. Okay. And if you have this OR here, if you have OR here, this is called an additional rule. Okay, if you have a OR here, when you use the additional rule, make sure you don't over add, okay? And this, if it's mutually exclusive, you just add both of them all together. But when it's not mutually exclusive, you add both of them together, you must minus the common part once so that you don't overcount that way. All right. So that is all this chapter, all about this probability in here. And how about take a 5 minutes break, and then we will come back to do a little bit of practice. Okay, and then separate into group that way.